Today's speaker is the former UK Region Director for ICEA, the current chair for SCAF, the Society for Cost Analysis and Forecasting, which is our sister organization in the UK. Sanathanan Rajagopal from Kinetic is a global expert on software obsolescence, a heck of a photographer, and an exhausted father to an energetic toddler. And he's here today to talk about some myths and facts about software cost estimating. Sanath?
Thank you. Thank you, Megan, for the introduction. Yeah, I'm exhausted. I have to run behind a toddler who's about 16, 17 months old. If I say that, my wife is going to kill me. She's going to say, you don't know how old my son is, and I'm a cost estimator. Right, okay, so welcome all. I'm going to talk about software estimating. This has been my favorite topic. This is a very high level chat about some problems, or where the problems is, myths and perceptions and stuff like that. So it's not at all technical, it's just theoretical, and we're going to go through to see where the software estimating problem actually is. Well, in my perspective anyways. So, right, this bit of introduction. All that in there, all what Megan said. I got a bit of a publication list, and the last year I worked with a Department of Defense and Defense Logistic Agency to get obsolescence paper underway. So that's one of my publication, recent publication last year, and I edited the COSMIC, which is a software sizing methodology document or guidelines in UK last month. So that's a little bit about me. I work for a company called Kinetic, and I'm an estimating manager for cyber and information. Just one slide on what Kinetic does, because I have to do this. Kinetic has been in worldwide locations. We got 85 plus location, and we got 1,300 patent, including 300 plus pending at the minute. We are moving from 833 million pound revenue to 2 billion pound revenue in the next couple of years. So that's a bit of a overview about what we do in Kinetic, and 60% of our workforce has got PhDs and things like that. Okay. Right, so in today's webinar, I'm going to talk about the difference between software and hardware estimation, some myths, perception, facts, and checking of the reality in general, and then software engineering problem. I'm going to talk about where those problems are. Is that in the software sizing or software development lifecycle? I'm going to conclude by understanding where the problem is. Originally this presentation was supposed to be face-to-face, and then we're going to walk through and talk through the through those perceptions and have an interactive session. Now, not sure how I'm going to do that here, but probably won't get those level of interaction, but I'm going to walk through those, and then you'll get at the end you'll get an opportunity to ask questions or have a discussion about those things. This is my personal view and does not represent views of my company. I've got to put a disclaimer there. This is purely my observations based on what I've been doing over the last few years on software estimating or cost estimating. So, talking about software estimation, why software estimation is different to hardware. Okay, now, Weinberg in 1998, he famously said, programming is one of the hardest intellectual tasks that a human being have ever tried to do. So software programming is very difficult and it requires a lot of concentration and a lot of effort to create a software program. Now, essentially, every part or everything that we see today or use today has got software. So it's solving human problems, right from you wake up in the morning, right from the toothbrush that you use to, the transportation you take, the work that you do, even the microwave, your refrigerator, everything has got software or some element of software in there. So it's essentially solving our day-to-day problem. Hence, it is difficult to develop one of those in a software program in there. So that's the reason why Mr. Weinberg says one of the most intellectual and hardest intellectual tasks for a human being. Now, moving on, what is software engineering? Okay, so this is from Software Engineering Economics. Software is a set of programs, procedures, and related documentation associated with the system. So that's what a complete software package or software is. So you're not just getting software, a program, you're getting all the procedures, and process, and all the documentation. That's a package. Now, what is software engineering then? So software engineering is the use of those software or application of those in science and in mathematics, which the capabilities of computer equipment are made useful to man via computer program, procedures, and associated document. Okay, so software engineering was that terminology is very new. In 1968, that's roughly about that time when they termed software engineering publicly. So it's fairly new. Now, why do you think software is different to hardware? Now, this is very high level, very general, few points in there. There are several other points that you may or may not be aware of, but I just want to go through a few of the points here. Now, software engineering is a very new discipline compared to civil and mechanical and electrical. That's given. Software doesn't weigh anything. It doesn't weigh anything. You can't see software. It's invisible. It is a program. Software programmers code it and put it in a system. You can't weigh. You don't know. With hardware, you can see physically. You can see. You can touch them. You can feel them. You can understand what that particular hardware is made up of. But that's not necessarily the case with software. It's invisible. It always increases. Have you noticed that? And with hardware, you have to put an extension to the building to see the increase in the size of your hardware. But with software, every update or anything that you need to change, software sizes increases. It's intangible. It's highly complex. It doesn't follow the laws of physics. Software definitely doesn't follow the laws of physics. For example, you're in a tank and you're firing, and you miss the target. In olden days, the old generation tank, you manually adjust the turret, and then you fire again, and you're adjusting the target. However, in the modern tanks, you got software that does that for you. It looks at where the shell is landed, automatically calculates and readjusts the turret, and off you go. And software is malleable. You can shape software to do anything. So that's the reason why software is different to hardware. Now that's the physical or the higher level difference between software and hardware. So think, looking at those perspectives, I've seen, and I'll put down few points in there which I came across while speaking to various people in my cost estimating career so far about software estimating. And these are a few comments that I've got. And because I do this more often, not now as such, but I used to do this more often, and I've came to a different conclusion to this statement. So this is the stuff that I wanted to talk to you guys about. I heard a statement where I say software is difficult to understand. Now, not sure what you guys think, but I think it's not as difficult as any other engineering discipline is. Now, if you look at when you wanted to do an engineering degree or engineering element, you choose your field of engineering, be that be electrical, mechanical, civil engineering, some your software. At that particular starting point, every engineering is as difficult as it gets. But as you progress further, understanding the software, it doesn't, or software or any of the discipline is not as difficult as it sounds. So it's the case of changing your attitude and aptitude towards the discipline. But I don't think software is difficult to understand. Yes, it's got lots of algorithms, it's got lots of formulas and command structures and stuff like that. But it's the same thing with aeronautical engineering. You got complex physics, formulas from physics and all that kind of stuff. So it's as difficult, but it's not difficult to understand. The other statement that I found and is fairly reasonable, fairly new that I found is, I heard people saying software estimation is a black art. I disagree, and that is a myth in a sense. It's not a black art; it is a science. We know, we're going to go through. I'm going to go through those different scientific ways, right? We can measure the software and things like that in a minute. But I don't think it's a black art. The other statement that, and this is true more or less in UK, software costs are estimated under system cost. It is true that it's estimated. That's purely because there's less knowledge within the cost estimating community on how best they can estimate the cost of software. So essentially, they group under the system, which is not a bad way of estimating, because hardware and software is the two sides of a coin, and that makes a system. So system consists of software and hardware, but there's no separate cost line when they estimate the cost for the hardware and the software. They just call it as a system. That is not an appropriate way of estimating. In a sense, the other statement that I came across was software cannot be measured in any form, therefore difficult to estimate the cost. Now that's not true in a sense, and we're going to talk about that in a later stage in today's presentation. Software can be measured, and we're going to talk about that. So that is a myth or a perception, whatever you want to call it, but that's not a true statement. Software is added as a risk. Well, I've seen this happening. It's purely because the people don't understand what software can do, and how to estimate the software sizing or the share, doesn't know anything about the software. So what they technically do is they add software as a risk, and they're going to say, the software is always late. I know that's going to cost you more, so I'm going to put 20% on top of the cost, and I'm going to put another 20% as a risk, because there are high chances of that software in going, overrunning and all that kind of being expensive and stuff like that. So I've seen that happening, and that's purely because they don't understand the software in a competent way to assess the cost of it. Systems are driven by software. That's another statement, which is true. Yes, a system has got hardware and software, and now hardware is essentially becoming more cheaper compared to software. Now, the classic example being would be Microsoft. Say in about 10-15 years ago, you can buy a laptop and you get software or operating system for free. That's how cheap it was at that particular time. Hardware was the expensive bit, and the software you get it free. Now, recently, Microsoft, before they introduced Office 365, Microsoft was looking at the best way to manage their overhead cost. And would you believe, one of the key overhead costs is in the service or support system. So that's where the overhead is. So they try to reduce the service part of it, and they said, okay, we can, the one way that we could, or Microsoft could reduce the overhead cost was giving away, charging for the software for Office product and giving the laptop free. So essentially, you don't get, you get rid of that particular service element or overhead element where people calls the service center and say, how do I install Microsoft Word and all that kind of element. So they're going to provide this software and the laptop free with it. However, they introduced Office 365, which is cloud-based architecture, and you get the software and they update the software. So they got rid of that overhead anyway. So software is becoming much more cheaper now. Now, the increasing resources will increase the productivity. Now, that statement is not true for software. Yes, it is true for any hardware. So if you go into a production line, a manufacturing car manufacturer or a production line, and if you're running or if you're delayed in producing substances, you can always inject extra manpower. Now, that's not necessarily true with software. Remember, well-being statement is the intellectual, highly intellectual task. So you're sharing your knowledge with the extra person that is going to come and help you out. It will delay your progress in software development. Now, the last topic is a favorite of mine, and actually I'm doing a PhD on it at the minute. I'm nearly finished now. It says software does not get obsolete. Now, there are two field of thoughts in that statement. Software does go obsolete, that's for sure, but not because of its own fault. It's everything else surrounding that particular software goes obsolete, hence software goes obsolete. In a sense, software on its own, the code or that stuff that what it's supposed to be doing, it stays there in their own environment. So technically, it doesn't go obsolete. So those are the few points that I picked up over the years, key points, and here we go. So that's cleared a lot of confusion in software estimating. In software estimating. Right, okay, moving on. Now, so software crisis. So where is the problem, and what is software crisis all about? Okay, so software engineering was termed, as I said previously, at a NATO conference in 1968. So the problem at that time was all the software that's getting released is unreliable, it's delivered late, it's prohibitive in terms of modification cost, it's impossible to maintain, it's performing at an inadequate level, and an inability to estimate with accuracy the cost, resource, and schedule requirement for software project, it exceeding the budget cost. Now, if you look closely on it, those points were identified in 1968. We still got that problem. We still got all those problems. We progressed a lot from 1968. We know a lot of things changed. We are evolving in the software engineering field, but we still can't get the software projects and program under control, and it always exceeds the budget. So this led me to think where the problem is. Where are we not able to fix the problem? So that's what this webinar is all about. Okay, now again, this is just rough order of magnitude flowchart. This is something that I just created just to showcase where things might go wrong, and where are we focusing and where we need to focus. Now, essentially in defense environment, you always have, the requirement is generated by three different aspects. Okay, you will have a new capability and a new platform. so that generates a requirement, or you will always have a new capability that needs to be merged into an older platform, or you got an older capability that needs to be integrated into new platform. So all three different types of projects generates a requirement. From that requirement set, you got system engineers who looks into the requirement, and they create user requirement documents and system requirement documents, etc., on the business cases and all the finer details of project and program management. So system architecture takes all the documents in, and they try to build what the software or system is going to look like. They create a lot of different models. For example, use case model. They look at class model, object-oriented model, UML, etc. From there, that's given to the software designers who design the software, and then give it to the developers. They develop the software, and then it's been tested, and the software get released. Now, about here, you go. So the software cannot work on its own. Either it gets integrated into with other software, or there's a hardware integration. So you're looking at software to software integration and software to hardware integration, and then that makes the system. But this is the field of our expertise. This is what we estimating the cost for. There's a capability, there's a from that requirement capability. Requirement has been captured, and this is the field that we estimate the cost for, and that's the product that we deliver. Now, in order to do this, in order to understand the cost of this particular element, we got various different methods and attributes that helps us to generate that cost estimate. So let's go and have a look around to see what is available for us to do that particular cost estimating effectively and efficiently. Now, software sizing. So like any hardware, you need to if you're building a building or an office block, you can actually see how that's been built, brick by brick, the electrical wiring, the plumbing, and the data connectivity and all that kind of stuff. You can physically see. With software, that's not possible. So, however, we still can size the software, and this is how we're going to size the software. So there are various methods. There's not a single method. Like in hardware, you measure by weight and a size and mass and things like that. Similar to that, in software world, we can measure the size of the software by function point, source lines of code. We got different attributes of function points or different standards like international function point user group, IFBERG or cosmic or story points or object points. So there's our various methods where we can know the size of the software. Like any hardware development lifecycle, we also like in academic lifecycle, or which is used by UK Ministry of Defence. There are software lifecycle. Now we got not one or two development lifecycle. We got plenty, in fact. From starting from code and fix, Waterfall, prototyping, which include agile, incremental, iterative, evolutionary, and spiral. So we got various different ways of sizing the software, and we got various different ways of looking at software development lifecycle. Now I'm going to talk about software development lifecycle in a little bit more detail. I'm not going to go through it. This is not technical. This is just high level. I'm just going to wish through individual life cycles to see. So remember, we are trying to identify a problem, where the problem is. So we're going to wish through those development life cycle. As every hardware development activity, software also has got a very similar development activities. We need to plan, we need to we need to produce, develop the software. So it's actually coding and all that kind of stuff. We need to test it, we need to document the software, we need to deploy, and we need to maintain. It is no different to hardware estimating. It's very similar to hardware estimating. Now, The waterfall. This is the classic development lifecycle that's been used for in software world. So you need to have requirement, then you're going to design based on the requirement, you're going to develop and then implement, you're going to verify, and then deploy it, and then you're going to do the maintenance of the product. Now, this is valid if all the requirement can be specified before and is stable. So anything changes in the requirement, we have to redo everything. So this needs to be fixed. This needs to be stable. Otherwise, this life cycle will not work. Now, the second one is the incremental one. You got requirement. You're going to design the product. So you're going to release the first increment. And then first increment, called test, deliver, and then you're going to increase the second, and you're going to deliver the second increment, and then it goes on and on and on. And this is valid if all requirement for that increment be specified before any design or implementation is conducted, and requirement should not change within the increment. So each increment, the requirement should be stable. The next one is the iterative one. So what you're doing in here is you're planning, the requirement, doing the analysis and designing and implementing, deploying it, or testing it, evaluating it. It just goes on iteratively. So as you reach here, you're deploying it, and then they come again and they say, okay, so we need to do this again. We need to change a little bit, and this goes on and on. With iterative, the requirements are incomplete, and we seek to discover them as we go along. So it's not, a requirement is not fixed. We don't know what the customer needs. We know we need a product, but we don't know what and how we're going to shape that product. So this is perfect for that kind of approach. So iterative. So this is where you're going to do a lot of requirement gathering, refinement. You're going to do a quick design, build prototype, custom evaluation, refining prototype, and then you're building a product. But this goes on and on. It's every iteration they do that until they get a final product. Now this is also got limitations. So typically with evolutionary, so my apologies, this is an evolutionary development lifecycle, not iterative. With evolutionary, the requirements are never complete. We stop when the money or time runs out. Same with iterative. We can only stop when the money runs out because the requirement is not stable. Now, so if you can see in this slide, I'll try to show you what kind of development life cycle is being used over the period. Now, I only got data up to 2008. I believe from 2008 onwards, there's a larger inclination towards agile, and now we can clearly see DevOps coming into play. Now, at a very early stage, it was code and test, code and fix, because it's very simple. Very, the software programs are very simple programs. It wasn't very complex, and then when around 2000. In 2008, you can start seeing a lot of complex software coming into play, and hence prototyping became so important. Where is the problem then? So we got we got a lot of different ways where we can measure the size of the software. We got different methodology to understand development life cycle. So we got estimating methodology. We can use bottom-up estimating with the size and how it's been developed. You can use parametric estimating methodology. So we can do a lot of different, come up with a cost of software with lots of different methods and methodology. Now, where is then the problem? Where is the problem actually? Okay, so we look at different life cycle methodology, and one thing that sticks out predominantly is here, requirements. So I came up to that conclusion purely because in modern time software or any software projects, or in defense, for example, in defense, from the requirement stage to actually getting the product into the users, it ranges from the time required ranges from anywhere between 2 to 10 years. Okay, now you cannot put a stable requirement for 10 years because the requirement will become obsolete the next day, especially for software or IT projects. So you cannot you cannot stabilize the requirement. You cannot say that the requirement is fixed, because technology insertion is happening pretty much every second or every day, every second of the day. So you cannot just fix the requirement and then work with the requirement, because requirement will get obsolete straight away. So the requirement changes. Because the requirement changes about here, everything else has got an effect on it, because everything else flows from the requirement. Because of that part, estimating becomes a little bit more difficult to manage. So so that I think that's where I came concluded that we need to have a stable requirement, but it's impossible for us to have a stable requirement because of all the other actors playing into that field. Not sure have we got a solution for it. I don't know, but certainly we don't have a problem with estimating. We can estimate the cost of software based on what we got now to a very good standard. However, if the requirement changes, we need to adapt the cost based on the changes in the requirement. I think that's where the problem is. Now, the other element that I found in this particular literature on this, software development literature called Software Development for Cost Estimating Handbook from EDU and NCCEA, the Naval Cost Estimating Group in US DoD. So it's interesting, and it's very, very true. So the scheduling part of the software estimating is a bit of a problem because we are very bad in estimating the schedule of a software estimating. Okay. Our estimating techniques confuses effort with progress, because we think we are uncertain of our estimates. Software managers often lack the courteous stubbornness of a chef. That's a very interesting point, because a chef says good cooking takes time, and if you are made to wait, it's just better and to please the customer. It's exactly the same. So if you wait, you get a good product out of it. But that is a huge problem, and we progress in a schedule progress is very badly maintained or monitored, and we more often put extra manpower to increase the productivity on software estimating, which is even worse because it slows down the progress. Now, this is kind of a conclusion slide. Where is the problem? I'll try to address where the problem is. I mean, this is just my personal view. I might be wrong. However, we need to have a stable requirement in order to get a proper estimate out. But the learning from this is we need to constantly change and monitor the requirement changes so that we can do the changes in our estimate. So we cannot just say that, oh, I estimated the cost, that's the final number. We need to revisit every changes that's happening in the requirement at the highest level to inform the changes in the estimate. If you look at, if I go back to the previous slide, the very start of, where the 1968 problems in here, this is as a cost estimator, this is beyond our control, but this is in our control. We can I won't say accuracy, because estimates are supposed to be wrong, but we can confidently create a cost for a software with all the available methodology and techniques that we got. However, we should be able to revisit, replan, understand the changes happening in the project throughout the life cycle to inform the decision makers of the cost of the estimate. So that's what all I've got for now. And yeah, any question? I'm happy to take questions now.
I haven't seen any questions come in. Oh, we've just gone to your desk. There we go. I haven't seen any questions come in, but I'll talk for a few minutes and give you shy folks some time to ask your questions if you would like to send them in. This is a reminder, we're down to 6 days for the abstract summary deadline for the 2021 workshop that will hopefully be held in Minneapolis. So it's only 75 words you've got to get to us by next week. You have more time, and you have until February to get your papers done and all that jazz. So you just have to know what you want to talk about and how you can tell our panel of review experts that your presentation is one of the ones we should put on the schedule. And that appears to have been enough to get a question out of Jeff Harris. One moment. Jeff, are you there?
Yeah, I'm here.
Fire away.
Yeah, thank you for your presentation. Just a quick question on kind of your conclusion there, which I think in my experience I'd agree with. But in yours, have you found the issue with requirements to be the growth of them, misalignment, underestimation of their impact or their magnitude, or some unmeasurable immeasurable combination of all of them? Thank you.
Yeah, thanks, Jeff. So it is a combination of all of those. It's not just one of the key element that I found was the requirement obsolescence. So the requirement became obsolete the day it was written off, because of the technology insertion happening. So so that one was the key one, but it's a combination of all that changes, all that you just mentioned.
Outstanding. It's a shame we couldn't. It's always a shame we can't have more easy interaction on these things because. Oh, perfect. Latoya, you're going to be next. Whenever you're ready, you can unmute yourself and go ahead.
Yes, I'm pretty new to software cost estimation, and I just wanted to know what are your thoughts on using Agile for software cost estimation, because that's what we do in our organization.
Okay, thank you for the question. I do hear a lot of questions about Agile. Agile is a development life cycle, and as long as you got a plan, or as long as you should have a plan within Agile. So how many iterations or sprints are you doing and things like that. So it should be easily manageable to do cost estimating. But however, remember, is another development life cycle. You can use Waterfall in Agile. You can use iterative. Agile is a combination of best method development life cycle that you want to use. So the only downside is it's good. Agile is with Agile you can break a huge problem or a bigger problem into a smaller chunk and address the issue that way. But the problem with Agile is sometimes most of the time it works on a smaller project, but in a larger project you get a lot of backlog, and you need to be able to manage the backlog effectively, and that's where the cost is. So it's okay to have a good plan. It's okay, you know what each scrum, what you're gonna do at each sprint, what you're gonna do, and that should inform the estimate based on the resources you're gonna include and all that kind of stuff. It's easily done, but you need to understand you need to look at how much backlog that's creating and what how efficient they are in dealing with the backlog, and that's where the cost is. and you need to include that in your cost estimate as well.
Excellent. We've got another one coming in from Bill Barfield. Bill, when you're ready, go ahead.
Can you hear me?
Sure can.
Super duper. Nice presentation on software. I've been pushing code since the early 60s. New languages and methods are one of the developers, but I find one of the best improvements or neatest improvements in coding is the various methods of automatic code generation, which is generating executable code straight from written requirements. What is your experience or opinion of costing this new type of technology?
Okay, so so you're talking about neural language. So basically, you can talk and it generates the code for you. Now, in order to do, you still need a program to develop that particular technology. Now, I haven't personally worked in the neural language as of now, but languages is a key driver for cost estimating. So depending on what just software development methodology is one, but the language is another key cost driver for software. So the newer or the 5th generation or later generation of languages carries it's expensive because there are less amount of people or less amount of skilled people to understand that particular language. And also, if you look at the old generation language, you still need those resources who understand the old languages, because if you look at military systems or military hardware, you still got people or you still got systems or software in circulation that's got COBOL and Pascal in use. So at the minute we don't have, or we have only got very limited resources who knows those particular language. So if you want to maintain that particular software system, you need that skilled people, so it's going to be expensive to maintain them. So yeah, 1st generation language and the 5th generation language is equally expensive. So the 4th generation language is on a normal scale. You can easily find people with those skill set. So yeah, that's my answer, but not sure if I answered your question directly, but I'm alluding the newer generation language will be slightly more expensive compared to the 3rd and 4th generation language.
The new language to generate code, right?
Yeah.
Whether that code is Ada or Fortran or the new languages of JavaScripting and so forth, still have to have a tool to generate.
Or MATLAB. It's not. You need. I'm talking about the resources required. So
right.
So generating the code, that software program can generate the code. The generating the code is not the issue, it's understanding. So the skill required to understand those language is the key. That's where the money is.
That's kind of like saying we will always need the graybeards.
Yes, I'm not disputing that at all.
Thank you.
Cool. All right, next one coming in is from Mel Etheridge. Mel, when you're ready to ask your question, go ahead and unmute yourself.
Okay, Sanath, a great presentation, and I could not agree with your conclusion more that requirement stability are fundamental to accurate cost estimating, and in my opinion, that applies to virtually any estimate. In your opinion, in your experience, how good are program managers at communicating the cost trade-offs when software requirements, new software requirements are added midway through the development cycle? How good are we at saying, well, if you do this, it will cost you this much money?
Okay, so that's a very relevant question and something that I'm facing at the minute. You got as a cost estimator, we are seen as a problem developer rather than a solver, So we always go with come up, this is what program managers or project managers think. We always come up with a problem. Oh, we can't deliver this because this is expensive, or the requirement changes, so this has got effect on that cost. Now, some programmers and project managers, they are very keen on understanding the overall cost and understanding how risky the program or the project is going to be. But some project managers are not so, not so much of a receiving end that, okay, so there's a change in the requirement, but we still can deliver this within the budget or within what's been allocated. So not looking at the bigger picture. So there is no direct answer to that question, but what we can do is to educate the program and project managers, give them the support that they need, and make them understand that, okay, there's a certain trade-off that you have to do because of the change in the requirement, and encourage program and project manager to revisit the requirement and look at risk and uncertainty because of the changes in the requirement. So the best thing is to work with them. Not all the program and project managers understand the change and effect of requirement changes in the cost.
Great, thank you very much.
Thank you.
Thanks, Mel. Next up, we have Mike Dean. Mike, when you're ready, go ahead.
Hi, Mike Dean from Connecticut in the UK, Sanath.
Hi.
Hi, very good, thanks. You touched on the poor estimating of time for the schedule. Do you have any thoughts on how that can be improved to help the cost estimate accuracy itself?
Okay, so okay, this is my personal view. We need a lot of education and project data spanning from historic project data and learning from those project data to inform our future. I think that's what we need to do. We need to keep an eye on changes in the requirement, look at the impact of the requirement into the schedule, and have and draw an impact, schedule impact into the cost. So schedule and cost estimating should run in parallel. And once you reach a point where you are able to do a schedule risk analysis, the effect of the change in the schedule, because you've not run a schedule risk analysis, needs to be incorporated into the cost. So, for instance, if because of the requirement changes, there's a schedule slippage of 6 months, that 6 month slippage will be in material, in this instance, in a software programming, or the resources. That needs to reflect in the cost, and that's how it needs to do. I mean, that's what I would do, and that's my personal opinion. But how do I improve? Have I seen this happening? So far, I haven't seen in a schedule being improved, getting improved in a software program is hard. That's why we go agile. So yeah, so I'm not a big fan of agile, but it certainly breaks down the bigger problem into smaller chunk. But so if you look at the history of all the software development lifecycle, one lifecycle is generated because there's a problem in the other lifecycle. So agile is a way of solving a bigger problem that's been happening in iterative or prototyping. So they bring in agile, but essentially, it's chaos with agile for a larger program. That's why earlier on I said you need to have an understanding of the backlog that it generates in agile programs.
Yes, I completely understand and completely agree as well. We do need to work on that a lot, I think. Thanks very much for your answer.
Thank you, much appreciated.
Thanks, Mike. Well, I think that may be the most questions we've gotten on a webinar yet. Well done. I think all of you listening have had your opportunity to send us a question, and if we haven't gotten one yet, I think we're about to close that window. If you have questions for Sanath, you can of course reach him at his contact information, which is on the screen. And if you're listening and weren't able to get that information, you can always email the ICEA business office at ICEA@ICEAonline.org, and we'll be happy to connect you. Before we go, I hope to hear from many of you or some of you next week. We're going to take a break from our software streak to go over to scheduling with Jonathan Shriekwe from Canada. And that's same time, same channel. So tune on in. I want to say thank you to Sanath for joining us today and for a great presentation. And thanks to all of you for listening as well. Sanath, do you have anything final to say?
Yeah, thank you for inviting me. It's been a great honor and a pleasure.
Absolutely. Well, I couldn't say it better than that. Everybody have a good rest of your day. Be good to yourselves, be good to everybody else, and stay safe and sane out there. Thank you.
Thank you.